Hi, my name is Daniel Olshansky, and today I'll be showing you how to do an animation to expand cells in a list view. So if you have a list view with certain data and you want to show extra content associated with every single cell, instead of taking the user to a new page, you can simply click on a cell, expand it, show the extra content, and collapse it. A few of the things about this animation is that as a cell expands, it moves around all the items around it to make room for the new extra content. And furthermore, this new size persists. So if you were to expand a cell, then scroll away from it and then come back to it, the new size will persist of the expanded cell until it is collapsed manually by the user by clicking on the cell again. A couple of the tricks and the problems that they came across while implementing this animation is the fact that when you animate a cell, when you change the layout of a cell, what's going to happen is that some of the other cells around it are going to disappear. They're going to be moved outside the bounds of the list view. And when this happens, you no longer have a reference to those views. So even though you still need to animate them to achieve that animation effect. That's problem number one. The second problem when working with this is that when you change the layout of a certain view in the list view, the container, what's going to happen is that the list view will try to rearrange the cells as it wants to make room for it. But if you want to achieve some sort of custom expansion, such that when you expand the cell, all the content should be visible, or as much of it as can be visible to the user should be visible at once, you're going to want to rearrange the cells in a way that's most optimal for your application. And in this case, you need to tell the list view exactly how to place them on the screen. So going straight into the demo, here we have a list view of chameleons, rocks, and flowers, and say click on a cell, see how it expands, displays a new text, and then you can click again to close it. This works for every single cell. It works for extra content of different sizes, and you can also see that as a cell expands and collapses, the extra content, the text, actually fades in and fades out. And this is not only restricted to text, this will also work with other types of layouts. Another interesting thing about this is that, say this cell is at the edge and you want to expand it, you can see that it'll animate in to make room for it. So if we were to animate to bring this flower down and we click here, it'll actually animate upwards instead of animating downwards. And then when I click on it, it makes room for all the other cells and animates them back in. So jumping straight into the code, here in custom list view, which extends the list view, which can expand and collapse cells, first we initiate an item click listener, such that when you click and click again, you can expand or collapse it respectively. And then scrolling down furthermore, this is the get top and bottom translations method. So what this does, this can be customized by you depending on what kind of user experience you'd like. But in this specific case, what I did is always try to maximize the amount of content that's displayed to the user. And all it is really just a little bit of math and a little bit of arithmetic, using the bounds of the list view, using what the current offset is, and using what the size of the list view, of the current visible part of the list view is as well. So this will return a bottom and a top, and all this will say is how much the bottom and the top bounds of the expanding or the collapsing cell should be modified by. And you can use these as a reference to animate all the cells around the cell that's being expanded or collapsed. Scrolling down furthermore, we reach the expand view method, which takes in the view that's being expanded. And before we actually expand anything, there's a few things we need to do. We need to store what the old bounds of the cell that's about to be expanded is. And we also need to store the top and bottom bounds of all the cells that are around the cell that's going to be expanded. After that, we get a reference to the expanding layout. So even though it's not visible at first, the expanding layout is present in every single cell, except its visibility is set to gone. So it's not being rendered, it's not affecting the layout at all. But by setting it to visible, we now tell it that we want to, and by setting it to visible and having the cell have its layout set to wrap content, what we're actually going to be doing is invoking a request layout call without having that be here explicitly, because we know that now something that was gone has to become visible and we need to render it. And like I've mentioned in a few of my other animations, what we're going to want to do is add an on-predraw listener. So by invoking setVisible, we're going to change the layout of this cell along with the bounds and the layouts of the cells around it. And on layout and on measure will get called. The final values for all the cells will be will be computed, but they will not yet be drawn on the screen. So this is the best place to run an animation. Except the thing about this animation right here that's going to be a little different is that we're going to have 2 passes in on pre-draw instead of just 1. During the first pre-draw pass, what we want to do is we want to offset the content in the list view in such a way such that after we invoke a layout once again, all the cells that we want rendered on the screen will be visible and will be accessible to the user. So if we were not to have this first pass, the list view would arrange all the cells in a way most convenient for this list view to display the content. But if this is not, but seeing how we're animating the top and bottom bounds in a very custom manner, what we need to do is specify exactly which cells we want to have visible. The way this is done is through a little bit of math, determining how much we need to offset it by. But the key method that I'm using here is set selection from top. So after determining which cell is going to be at the very top after my custom animations, my custom changes for the top and bottom bounds are run, I know what the first visible position is going to be afterwards, and I also know what its offset is going to be from the top. So doing some math, then calling set selection from top, I set the offset that I want for the list view, and then I call request layout. So what this is going to do is render all the cells that I need to be rendered on the screen after having the list view be offset by how much I need. I'm also going to be returning false from on pre-draw because all I'm doing here is offsetting the content, but I don't want the current state of the list view to be redrawn. So, because if I were to redraw it in 2 different states, it would be a very janky and not a very pleasant animation for the user. So returning false, but still not having removed the pre-draw listener, what's going to happen is it's going to come back to on pre-draw after the new values have been recomputed, at which point we will no longer need the pre-draw listener. So then we go down, we can retrieve the values from before for the top and bottom bound changes, and then we can get straight into calculating on the animations that we need. So before the animation took place, we stored the top and bottom bounds for all the cells that were previously visible. And so if it was visible before the animation and the cell is still visible after the animation, we're going to go into this else case, and all we need to do is animate the bounds from the before state to the after state, which is very straightforward. This is what happens when the parent, what I'm going to say was this is what happens when the parent of the view is not null. So this means it was visible before the layout change, and it's also present after the layout change. But say the cell expanded so much that the cell will no longer be visible after the layout change, we're going to see that our view's parent is null, so it's no longer contained in the list view. But up here, when I created my hash map, I set hash transient to true. So what that did is, even though it's no longer part of the list view, this view is not going to be recycled. And as long as I store a reference to this list view myself, I can still make use of it after the layout has taken place, as long as I have a reference to it. So scrolling down here, all I'm going to do is add the exact same animation as I do for cells that are still visible after the layout, except I'm also going to add it to this array of mine called mViews to draw, which is going to tell me that this is a view that needs to be animated off the screen just for animation purposes, but doesn't actually need to be rendered for the purposes of ListView, for the purposes of the ListView use. So scrolling down furthermore, I add an animation to actually expand the bounds of the cell being expanded, and then I also fade in the expanding layout text. So this does not necessarily have to be text, but the layout itself is faded in by animating its alpha value from 0 to 1. Then during the animation itself, I want to disable my list view to prevent some weird behavior that if the user were to scroll during that time. And once my animation completes, one thing that I really have to do is make sure to set the transient state to false for any views that previously had it to true, so that these views don't get stored but can actually be recycled and make list view scrolling more efficient afterwards. So that was expand view. Now in dispatch draw, what's going to happen is the only things that I would want to draw onto the screen that are not on the screen right now are views that were in the list view but are no longer in the list view afterwards. I only need a reference to these during the animation, because once the animation completes, the user should not be able to interact with them anymore. And so since I have a reference to the view itself, all I need to do is translate the canvas appropriately, just its top value, because the cell takes up the whole width. I just need to modify where it's located vertically on the screen. I draw the view onto the canvas, and then I translate it back so that the next cell to be drawn will be drawn in the correct location as well. Scrolling down furthermore into collapse view, it's going to be very similar in most ways. So before the cell is collapsed, I want to store the top and bottom bounds of all the cells prior to the collapse. I want to set transiency to true, so nothing gets recycled during the collapsing animation. And then the only important thing, really important thing to note here is that I'm not changing the expanding layout visibility from visible to gone. What I'm actually doing is setting the height of the layout to a custom height that I calculated, that I pre-computed before, which is what its default height is when it's in a collapsed state. And the reason I can't set the visibility to gone and just work with the layout change from there is because I want to get that fading effect as the cell is collapsing on the expanding layout. And that fading effect cannot be achieved if the expanding layout visibility is gone or invisible. So by setting the height to a custom value, I can then invoke a layout and add an on pre-draw listener like before. Very similar to the expand view method, I'm going to have two passes. The first pass is going to offset the list view in such a way to account for the custom collapse that I'm going to achieve. And once again, I'm going to call set selection from top, request a layout, and make sure to return false so the transient state of the list view does not get drawn onto the screen. And then since the pre-draw listener has not yet been removed, when a request layout has been called again, it'll come back here for its second pass, where I will firstly loop through all the visible children in the list view. If I find that I do have access to the old bounds of that view in the list view, that means that this view was present in the list view before and after the collapse, at which point all I need to do is update its bounds and then later animate them. But if I find that I don't have access to the old bounds of this cell, that means that this cell became visible only after the collapse of the view. So the collapse of the view actually made room for new cells to appear. But since I don't know what their old bounds were, I don't have a reference point from where I want to animate them. So I use the top and bottom translation values to account for that. Scrolling down here, I loop through all these same views and add the animations to actually animate them from these old bounds to their new bounds. I also want to animate the collapse of the collapsing cell, and I want to animate the expanding layout from a value of 1 to a value of 0, so it disappears. Then I play all of these together in an animator set, and then once it's actually done, what I do is set the expanding layout visibility to gone, so it doesn't get rendered on the screen at all anymore, and nor is it visible. And I also update my layout parameters to rep content, because when it's gone, I want to just wrap the content, which means that none of the expanding layout should be wrapped. And then here, get animation. This is actually how I animate the top and bottom bounds. Since top and bottom have associated setters in views called set top and set bottom, these values can be animated as I would like for them to be, and then I just return an object animator that does what I need. The one other thing that I wanted to mention in this animation is how I actually managed to achieve the collapse of the expanding layout while fading it out. So what's going to happen is when I set the height of the layout to be a collapsed state, the list view will not want to render the expanding layout because it's not visible on the screen. So what I do here is override onMeasure, onSize, and onSize changed. And what I'm telling it to do is that when it doesn't want to display the expanding layout content, but if it previously was in an expanding layout state, by overriding onMeasure and returning the bigger height as opposed to the smaller height, will keep it visible, and that lets me animate its alpha value. And once it's completely collapsed, that's when I set it to gone because I don't have anything else to do with it. So that's how you can expand and collapse cells in ListView Thanks for watching.